What is a momentum? Momentum is denoted by the letter P, which is nothing but the product of mass into velocity. So weight is nothing but the gravitational force exerted by the earth on a body. If an object is attached to a rope or to a string or to a thread, there is a force exerted by this thread, rope or string on that object which is connected. We will call it as tension. Hello everyone, welcome to session 2 of chapter 5, Laws of Motion. In the previous session, we have studied about the motion, the laws which governs the motion, which is given by Sir Isaac Newton and very famously called as Newton's laws of motion. We already had a discussion about Newton's first law, Newton's second law and third laws of motion, and also various terms, various factors which are needed to understand these laws. So in today's session, let us discuss few more topics related to a motion of an object, under which the first important thing is conservation of linear momentum. What is a momentum? Momentum is denoted by the letter P, which is nothing but the product of mass into velocity. We have discussed about this momentum. How does this mass and velocity varies momentum? How does the momentum depends on the mass and velocity from examples in our previous session. So now we are saying that this linear momentum is conserved. The total momentum of a body which is traveling with one velocity and the other velocity remains conserved in nature. How does it? Let us understand. So the statement of conservation of linear momentum is the total linear momentum of an isolated system interacting particles is always conserved. It remains unchanged. So the total moment of an isolated system of interacting particle is always conserved. Here you can observe we have two masses m1 and m2 which are moving in the same direction with initial velocities u1 and u2. So this is before collision of the particles. When these two objects collide each other, one object will exert force on the other object and the other object will exert force on the one more object. Say for example, M1, M2 are the two objects which are colliding, and this F21 is nothing but the force exerted by the second object to the first object, and F12 is nothing but the force exerted by the first mass to the second mass. So now you can observe the direction. The force is in opposite direction because of the force exerted by the objects are during collision, so it is opposite. And after collision again the masses will travel with the different final velocities. It is given by V1 and V2. So this is the statement of linear momentum. Let us now understand how can we say that these momentum are conserved. So for that we have considered two bodies, body A and B, which are traveling with initial momentum PA and PB respectively, where P is momenta of a body A and in case of PB, P is a momenta of body B, since they are vectors and we have to represent it by a vector sign. So the bodies collide, they get apart. When the bodies collide, they get apart because of the exertion of force. So the final momentum of bodies are given by PA dash and PB dash respectively. That is the final momentum of body A and final momentum of body B. Now according to Newton's third law of motion, during collision, a body collides with the other body, the direction of force will be opposite, which means for an action there is an equal reaction according to Newton's third law of motion. So we can write the expression for force, that is force exerted on A by B is equal to force exerted on B by the body A but in opposite direction, and hence we have to denote it by a negative sign. Here FAB is nothing but the force exerted on A by the body B, and FBA is force exerted on B by the body A. They both will exert force but the direction is opposite, and hence we have to denote it with the negative sign. This is my first equation. And if delta t be the time for which collision takes place, so that is the small time interval where the collision takes place, the impulse acting on the body E is given by FAB into T, because we know impulse is nothing but the product of force and time. So impulse acts on body A is nothing but FAB into delta T is nothing but the change in momentum. That is, change in momentum means final momentum of object A minus initial momentum of object A. So here we are finding the impulse on A. Since we are finding the impulse on A, that is the force into time, the product of force and time, we have to write the change in momentum as P dash A minus PA, because we are talking about the object A, and impulse is nothing but change in momentum. That means the final momentum minus initial momentum. So we have already defined what is final momenta and initial momenta. Similarly, the impulse acting on B is given by FBA into delta T, which means force into time is impulse, which is nothing but the change in momentum of the object, that is P dash B minus PB. Now from the equation 1, what do we have? Equation 1, FAB equals minus FBA. So from equation 1, let us substitute these two. So FAB is given by P dash A minus PA, which is equal to minus of FBA. FBA is again P dash B minus PB. Now we can interchange these two terms and we can write it as P dash A. Take this to other side, this minus becomes plus, plus P dash B, which is equal to, bring this PA to other side, will become plus. So we will get PA plus PB. So which means that the total final momentum is equal to total initial momentum. Here P dash A and P dash B are the final momentum. The sum of final momentum is equal to sum of initial momentum, which is nothing but the law of conservation of momentum. So now let us understand the other few important concepts in the study of motion, that is the common forces in mechanics. What are few common forces that exist in nature which helps us in understanding mechanics? For one of which is weight. What is weight? It is very important to know about the difference between mass and weight. They are not same. Mass is nothing but a quantity of a body. Weight is nothing but the product of mass and acceleration due to gravity. Mass remains same everywhere. Wherever we go, the mass of an object remains same, whereas the weight of an object will vary because it depends on the value of acceleration due to gravity. So weight is nothing but the gravitational force exerted by the earth on a body. Generally, it is given by an expression W is equal to mg, where m is mass of the body and g is acceleration due to gravity. As I told, the weight of a body always depends on the value of acceleration that is exerted by a gravity. Now, its direction is along the vertical and it is always towards the center. So, weight's direction is always towards the center, since it depends on gravitational force and it is always vertical. So next we have tension. In physics, the terms stress, strain, tension, pressure are always common. So we will use all these terms so oftenly, and we have to know what is the meaning of tension in physics. It is nothing but the force exerted by a string or a thread or a rope, etc., on an object to which it is attached. If an object is attached to a rope or to a string or to a thread, there is a force exerted by this thread, rope or string on that object which is connected. We will call it as tension, and it can be written mathematically as T is equal to M into G, where M is nothing but the load placed in weight hanger and G is acceleration due to gravity. So the tension on any object depends on its mass and the value of acceleration due to gravity. Now let us move on to an important concept of the chapter laws of motion, that is friction. Friction is also a term we have to know because we will undergo so many applications of it in our daily life. So let us study more about the topic called friction. It is nothing but the property of virtue of which the force opposes the relative motion between two surfaces of bodies in contact. Say for example, we are walking on a ground. So a human who is walking on a ground, a man is one object and the ground surface, his feet is in contact with the surface of the ground. So there develops an opposite force which is opposite to the relative motion. This opposing force is called as friction, the property by virtue of which the force opposes the relative motion, and we will call it as frictional force. What is the cause of this friction? How does it causes? So the frictional forces are due to the roughness of the surface, and also sometimes it can be due to the molecular contact of the surface and an object. So the molecular force of attraction at the points of actual contact. It can also be depends on the nature of the surface. Say for example, if the surface is very smooth, the friction is different. If the surface is so rough, the friction is different. So the cause of friction may be a nature of surface, or it is due to the molecular force of attraction at the contact point of two objects, or it is due to the roughness of the surface. So this is the cause of friction. Now we will understand what is frictional force. It is nothing but the force which opposes the motion of one body over the other body which is in contact with it. If the one body is moving on the other body, it is nothing but the force which opposes the motion of one body on the surface of other body. We will call it as frictional force. The direction of frictional force is tangential to the two surfaces in contact and opposite to the relative motion. If a car is moving on a road, here the force which is opposing the relative motion, that is the tire's wheel with respect to ground, we will call it as frictional force, and the direction is always tangential to the relative motion. And the direction of friction is tangential to the two surfaces which is in motion, and it is always opposite to the relative motion. The direction of frictional force is always opposite to the relative motion. So the force that opposes the relative motion between one body and the other body, we will call it as frictional force. Now let us see what are the types of friction. So we know what is friction now, what is the frictional force meaning. Let us now study types of friction. The first one is static friction. We know what is the meaning of static, which means the state of rest. So here it is saying that it's a frictional force which balances the applied force when a body is in the state of rest. Which means, say for example, if a body is in the state of rest, we are considering a huge mass and if man is trying to push it, it will not change its position because here the surface and the body have some friction between them. So that is what we are going to explain now. Consider a body on the floor. Whenever the body is pushed with a small force, it doesn't move. Why? Because the floor exerts a frictional force on a body. Since there is a frictional force between these two, if we apply small amount of force, the body will not displace. So this frictional force which balances the opposing force. Static friction is always equal and opposite to the applied force. Static friction means the friction when the body is said to be at rest. It is always equal and opposite to the applied force. Because static friction here generates will be opposite to the applied force, and hence since these two forces are equal, the body will not change its state of rest. So next we have normal reaction. What is the meaning of normal? Normal generally says that perpendicular direction. So it's a body placed on any surfaces experiencing a force which is perpendicular to the surface. If any body experiencing a force which is perpendicular to the surface, we will call it as normal reaction. If the body is at rest on a horizontal surface, the magnitude of normal force is equal to weight of the body. So here the normal force is equal to the weight of the body when the object is placed on a horizontal surface. So these are the various kinds of friction we are studying. So friction is one of the important concept. As I told you, the application of it is wide and vast in our daily life. So next we have limiting friction. What is the meaning of limiting friction? It is the maximum static friction that a body can exert on another body in contact with it. Maximum static friction that a body can exert on the other body which is in contact. It is also called as self-adjusting force. Limiting friction is also called as self-adjusting force. So it's one of the important type in friction. Next we have the force of limiting friction is directly proportional to normal reaction. the force of limiting friction is directly proportional to normal reaction between the two surfaces. So how to remember this, how to understand this? By the expression F is equal to mu into R. So this can also be written as mu S is equal to Fs divided by R, where mu S is the coefficient of static friction. It is the ratio of force of limiting friction to the normal reaction between the surface. Fs is nothing but the force of limiting friction. So coefficient of static friction is a unitless, because in numerator also we have force and denominator also we have force. So since both are of same quantities, there is no unit for limiting friction. Next we have kinetic friction, which is denoted by Fk. What is kinetic friction? It is the frictional force acting between two surfaces when one surface moves over the other. For example, consider a body moving on the surface of another body. The kinetic friction acting on the body due to the surface of another body will be opposite to the direction of motion of the body. For example, if we have two bodies, one body is moving on the other body, then the kinetic friction of one body that acting on one body due to the surface of another body, it is opposite to the direction of motion of the body. So the kinetic friction develops there is always opposite to the direction of a moving body. What is coefficient of kinetic friction? It is given by the letter mu k. So mu means coefficient of kinetic friction. It is the ratio of kinetic friction and normal reaction between the surfaces. It is given by mu k is equal to Fk divided by R, where Fk is nothing but the kinetic friction, R is the normal reaction. In the study of kinetic friction, we have a concept called angle of friction. What does it mean? It is the angle made by the resultant of limiting friction and normal reaction. It is the angle made by the coefficient of limiting friction and the normal reaction. We will call it as angle of kinetic friction. Angle of sliding is nothing but the minimum angle of the inclined plane. The minimum angle of the inclined plane for which a body lying on it just begins to slide down. If a body is lying on this inclined plane, when it just starts sliding down, what is the angle for this reason? The minimum angle of a inclined plane for which a body which is lying on it just starts sliding down, we'll call it as angle of repose or angle of sliding. Next type of friction is a rolling friction. So what is rolling friction? It is the frictional force developed when one body rolls over the other body. When one body is rolling over the other body, there is a friction between these two bodies, and the name for such type of friction is rolling friction. Now, let us know about the laws of friction. So far, we have studied what are the types. Let us now study about the laws of friction. So, the direction of the frictional force is always opposite to the direction of relative motion of a body, one body over the other body. The friction always exists between the surface of two bodies. So, here the direction of frictional force is always opposite to the direction of resultant or the relative motion of one body with respect to the other body. The magnitude of frictional force is always directly proportional to the normal reaction. So, when two surfaces are in contact, the magnitude of the frictional force is always directly proportional to the normal reaction. The other law is the magnitude of frictional force depends on the nature of the surface and their state of roughness, because we know friction causes due to the nature of surface. So the magnitude of frictional force, how much is the frictional force that exists between two surfaces, that depends on the nature of surface and their state of roughness. And also the magnitude of frictional force is independent of shape and area of the surface. So the magnitude or the value of frictional force does not depend on the shape of any object or area of any object, but it depends on the nature of surface or the roughness of two surfaces which is in contact. So far we have studied so many things about friction. Let us now see what are the advantages of friction. Yes, there are so many advantages of friction which we come across in our daily life. Because of friction that exists between the foot and ground, we can walk on a ground. Because of that friction that is opposing force that exists between a pen and a paper, we are able to write on it. So like this, we have so many applications in our daily life. Let us see few of them. So one is, it is necessary to walk. As I told, if there is no friction, we will slide over the surface. We may fall. Because of the existence of frictional force, we can easily walk on a floor. And to write on a paper, we need a friction. So frictional force is necessary to write on a pen. If there is no friction, the pen nib will just slide over it, and there will be no grip to write on a paper. So to get that grip, there must be a friction. And to count the notes, there must be a friction between the hands and the note, the surface. Between these two surfaces, there exists a force, and that is called as frictional force. And for working for brakes of automobiles, there exists a friction between automobile brakes, because of which the vehicles can be stopped. And for lighting a matchbox, while lighting a matchbox, when we rub this matchstick with the matchbox, there exists a friction between these two surfaces, which in turn develops a fire. So there also we can observe friction. And also for nails and screws to hold things together. So we will put that nails and screws to the walls to hold the things together. There exists a frictional force. And for walking and playing, to climb a tree and to do so many things, there must be a force called friction that exists between two surfaces in contact, which makes our work easier. Next, what are the disadvantages of friction? These are the advantages what we have studied so far. Let us now see what are the disadvantages or the limitations. It reduces the efficiency of machine. Because of friction there exists between the screws or nuts and bolts in the machine, the efficiency of machine will be reduced. That is one of the major drawback of friction, and it causes wear and tear of machinery parts. Because of friction, the rubbing of parts inside the machine, there causes a wear and tear, which again causes a major damage, one of the greatest drawback. It produces huge amount of heat, which is harmful to the machines. So when the machine is undergoing friction, or if inside the machine there is a friction between the parts, that causes huge amount of heat, that results in huge amount of heat, which is not good for the machine health. And that is again a drawback. And speed of automobiles cannot be increased beyond a certain limit. Because of this friction in the accelerator, speed of automobiles cannot be increased. These are the few drawbacks of friction what we can observe in our daily life. So in this session, we have studied about the concepts of linear momentum, how can we say it is conserved, and also the concept of friction, its types, advantages and disadvantages. In our next session, we will study few more interesting concepts regarding the motion and its laws. Until then, keep learning all of you. Thank you so much.